in the set. Wait, what's been put in 57?
Okay, so
Do 48.
Yes.
57
There's
is
no letter.
very similar to one of the quiz questions from 2 days ago. We've got an acceleration. It's a constant acceleration. They even tell us that it's negative 32. How is that apropos? That's why it's you're accelerating downward. What's that 32 come from? They gave it to us, but what is it? Yes, the force due to gravity, acceleration due to gravity. Okay. In metric, it's negative 9.81, negative 9.806 on average. In terms of imperial units, negative 32 feet per second squared. Okay. So, a ball was thrown vertically upward from the ground with an initial velocity of 60 feet per second. How high will it go?
Yeah, I think that one has 30 feet per second.
What problem is
57.
it?
The one you asked for?
There's 57 on both. On your side. There's two.
Well,
Oh, I meant 57 on the second.
Wait, what can we
Yeah,
still
yeah,
do?
yeah.
Yeah, we can do both.
Yeah, this one's involved.
Impossible. Oh my goodness.
Just like plug it in.
Yeah, it's supposed to be.
Okay, it's upward at 60 feet per second. So, how do we find anything? Given acceleration and speed. We talked about it briefly last week, and it's definitely in the reading. Yeah. You might have it in your notes, maybe, but if not, you got to get it in there now. Okay. Right, x of t is like your position, right, where you are. Your position, you give me the time, I can tell you where you are, x of t. How do I find the velocity or the speed?
X prime of t.
Yes, x prime. It's the rate of change of the position. And if you think about the units, right, the units of position might be like feet, and then the speed is change in position over change in time, feet per second, or meters per second, centimeters per decade, some sort of speed. When we're just talking about one direction, not the singular group, speed and velocity are the same thing. If we start talking about putting things at a certain angle, then it's traveling in like both the x direction and the y direction, then speed and velocity end up being different things. But when we're just traveling back and forth, just up and down, speed and velocity are the same thing. And what's the third thing that we care about? The double prime, what do we call that? Acceleration. So that's v prime of t. Yeah. Also known as x double prime of t. And then we actually named what comes next. Anybody remember what comes after acceleration? It's got some sort of weird, whacked out names. Deceleration is just acceleration in the other direction. The next one is jerk. Jerk is how fast the acceleration is changing, right? Speed is the rate of change of the position. Acceleration is the rate of change of speed. Jerk is the rate of change of acceleration. That's like when you're driving your car and you got the pedal to the metal and you don't get pushed back against your seat the same the whole time. Right? You get pushed back a little bit more, and then once you climb a little higher in the gear, it lessens a bit. The acceleration, the amount you're getting pushed back in your seat, changes over time. It's not a constant acceleration. So that's called jerk. And then the three that come after it have possibly the stupidest names in all of physics. The rate of change of jerk is called the snap. That one almost makes sense, right? The jerk is sort of like, how much your acceleration is changing, how much you're jerked. The snap, like the rate of change of the jerk. Okay. But then the next two, anybody remember the next two? The serial. Yeah, it's a snap and then crackle and then hop. Yeah.
Are you serious?
Yeah.
Snap.
It's really, really bad. Makes me ashamed to be a physicist.
I told you.
Although there's some debate, some people don't use hop for the
No, it is.
for the sixth for the seventh
Are you
derivative. Some
actually,
people
are
don't
you
use hop.
joking now, or are you
No, I'm being serious. Snap, crackle, and pop are the fifth, sixth, and seventh derivatives of position. Yeah. No, this one's real.
We have to worry about snap.
No, you do not. Nor do you even have to worry about jerk. We're only going to be talking about acceleration. Okay. Yeah. Somebody did. Okay. So let's take a look at number 57 now. We're told that the acceleration is negative 32.
Yes.
And we're told that the initial speed is 60. Well, what's the connection between acceleration and speed?
Acceleration is the thingy of
Yeah, well, yeah. So if we're given acceleration, how do we find the speed? Or what is the speed going to be? The antiderivative. And what is the antiderivative of negative 32? Yes. All right. Negative 32t plus c. Now, is there some way to figure out what c is?
Yeah.
For instance, with the information that they gave us.
Yeah.
What information did they give us if we wanted to put that in sort of a mathy language? What about 60? What is it? When? When t is 0. Right? That's the initial speed. So this 60 is v of 0. How do we use that to solve for c? Plug it in. V naught, v of 0, is, what is it in terms of plugging in 0? It's, 0 plus c. So it's c. And then we also know that that's equal to 60. Well then, I guess we know what c is. So what's our new equation for speed? So that's our speed. The question asks us to find out how high it will go. How are we going to do that? There's two good ways to do that. What's one way we can do that, Jane?
Find the max of the position equation, which is like, that's the derivative of the position equation, so you could just solve for.
Yeah, right. I mean, to find the max of something, we take the derivative of it. I'm going to go ahead and find x of t. Yeah, what is x of t?
Negative 16t squared plus 60.
Negative 16t squared plus 60t plus c. Oh, great, a new c. Huzzah. What, how are we going to solve for c?
Well,
X of 0.
you know the initial position
Yeah, what's the initial position?
at when t equals 0, it's at 0.
Yeah, it starts on the ground, they said. Starts on the ground, so initial position is 0. And probably more appropriately, I should have been using y of t, because we're talking about up and down, not side to side. But doesn't matter. Okay, so x of 0, if I plug in 0 for t, what do I get? C. And what do we know that x of 0 is? 0. Okay, so c is apparently 0. Well,
It's a second.
yeah, the first c was 60. If you want to call the second one a different constant, you may do that. But I've got an equation now for position. It's negative 16t squared plus 60t. That's the position. That's the speed. And we know that the acceleration is negative 32. And then, as James said, to find the max of something, we take the derivative, set it equal to 0. Same way we've been taking the max since before winter break. Okay, find the max, take the derivative, set it equal to 0. What's the derivative of x of t? What was that? Yeah, it's the speed, the velocity. Okay, or we could go ahead and just take the derivative again, either way. And then we set it equal to 0. Think about physics for a moment. When this ball gets to the top, what's its speed at the top? 0. Okay? That's why it makes sense, in this case, that's why it makes sense that to find the maximum height, we're figuring out where the derivative equals 0. So not only does it make sense just because we've been doing it that way for a while, but just physical reasoning, when it gets to the top, that's when its speed is 0. And that's as high as it's going to get. Okay, so where's the speed equal to 0?
T is 1.875.
Yeah, couldn't they have said that it was launched with an initial speed of 64? Okay, so T is 60 over 32, or 4. So 15/8 seconds. Almost 2. Almost 2 seconds. And let's make sure we answer the question. What was the question? How high? So the question wasn't at what time is it the highest. The question is actually how high does it go? And so yeah, we plug it in to the equation we now have for position. And it's whatever it is. Yeah, I could pull out a 4T. Whatever that messy looking thing is. Take it back, it's not awful. Cancel that's 2. Cancel that's 2. Oh, well, that's 15 and 15 halves. That's a 15 and a negative 15 halves. That's negative 15 halves. I'm going with 225 fourths or 56.25 feet. Don't forget units. Feet. Can somebody verify that so that my sloppy math didn't?
Yeah, that's right.
Maybe. I forget, did I also assign 59 for this one? Okay. Okay, so
Don't listen to
all right, 57 from page 262. Oh wait, 270. Oh right. Yeah. Probably. This whole thing we do not need. Okay, determine whether that function is integrable. 57.
On the other page.
Yeah, on the other side.
Really? X minus 4.
Yeah.
I mean, you guys beat last night.
Okay, so we're going to be attempting to find the area of that thing from 3 to 5. What does 1 over x minus 4 look like? We spent a lot of time on this last year. Those are my pre-calc. How do we graph? Yeah. Like on an actual graph. What does 1 over x minus 4 look like? Yeah. Not quite that.
An L.
Yeah, like there's an L.
It's like an
Yeah.
a soft
I thought you were drawing something.
I can't remember.
Yeah, but it's good.
Yeah, I would always do like a little bit because he's like it's
Maybe.
sharp, like no point.
Yeah.
Where is it shifted or something. What's the defining characteristic of this thing? So it's 1 over x minus 4. What does that mean? It's shifted to the right 4 because we've changed the x part to x minus 4. So obviously 4. And it looks something like this. Okay? And we're trying to find the area from 3 to 5. Yeah. I mean, if we were to draw the area, we haven't talked about what happens if it's underneath what looks like that. Okay.
This is where I got the idea when you can't cross the dot or the accent. Remember earlier?
Yeah.
Does it go like past 3 or we know it? Is that
Because it doesn't.
Oh, well, it shouldn't go past 5.
Okay.
Yeah, but we're only caring about.
Why don't you undo?
Because I don't want to undo. Okay. So we're only looking at that part. And is it possible to find the area there?
No.
Yeah, not if it goes to infinity like that. Just not.
So no, because it goes to
Yeah.
It's undefined.
It's undefined.
Yeah. Okay. You can look at the integral. Which defines the area, right? If we could find the area, that's what it would look like. But to get from 3 to 5, we got to go through 4, which means we'd have to divide by 0. And that's naughty. We're not allowed to do that. So no. Anytime you're either going to have an imaginary inside the integral, or anytime you're dividing by 0, then we're going to call that not integrable.
What was
Now.
the first one? Oh, it's imaginary.
Yeah, so like negatives inside square roots. Now, we could integrate with imaginary numbers.
Wait, the two
We're just
things
not
were-
going to.
The two things we couldn't do were what again? Divide by 0. What was the other one?
Imaginary numbers.
Imagine.
We're just not going to deal with numbers that aren't on the real number line in this class, okay? You can actually integrate. I is just a number.
Yeah.
The integral of I times x is I over 2 x squared plus c. So, okay. 50 and 5.
It's on page 248.
Yeah.
I was just.
Tree growth. Okay. So
Yes.
for the first 6 years, the shrubbery grows at a rate that looks like this. DHT is 1.5t plus 5. In other words, it starts at 5 feet tall and then grows 1.5 feet a year. Okay, that's where they got that equation. Okay. Plus. Yeah, that's why I had to start, putting little hooks in the wrong my teeth. Right about when I was your age. Way back when most of the cavemen were banging rocks together. Okay. So, how do we figure out the height? Oh, wait, what is the question? Find the height after T years. And how tall are the shrubs when they're sold? And we're told they're sold after 6 years. Okay. Take the antiderivative. This is dHdt. So h, or h of t, is what? 3/4 t squared.
Plus 5t plus c. That's plus 5.
Yeah. Okay. Yeah, so how are we going to find C? Yeah, they're 12 whole centimeters tall when they're born, or something. When they first start being tended. Okay. What's all that rate stuff? It's H's in centimeters.
It's embarrassing.
So how do we find C?
They give you.
Yeah, plug in 0 for everything, which is going to get us that C equals 12. Okay. When it's a starting condition like that, like they didn't tell us how tall it was after 2 years, they told us what it was when it started. It's usually pretty easy. Not always. For instance, if there were a cosine in there, cosine of 0 is not 0. Cosine of 0 is 1. So you got to watch out. You can't just randomly say, oh, it's a starting condition. So C is going to be 12. Works for polynomials, but there's other things it doesn't work for. So just go ahead and plug it in. But in this case, h of 0 is just C, and we're told it's also 12. So h of t is indeed 3/4 t squared plus 5t plus 12. And that answers one of the questions. Right? One of the questions was, what's the height at any given time? There it is. What it is. And then what else?
When it's sold.
Yeah, when it's 6 years old. And how do we figure that out? Plug in 6. And that's it. I mean, plug in 6, get an answer. 36, 9, 27, plus 30, plus 12, 69 centimeters.
Yeah.
Not quite a meter. Just over 2/3 of a meter. Okay? We can find a lot of useful information just from the rate of something, not just from the actual equation of something. Okay, what else? Push-ups.
Honestly, at this point, I'm already dead.
What numbers did I assign from 271 for the starting one?
1 through 9 odd, 11 through 19. Wait, I had a question.
Yeah, I want to make sure that
9.
we understand
Wait.
what's going on there.
Yeah,
Yeah,
9.
especially number 9.
Number 9?
That would have made sense.
No, that was.
Oh, I'm so sorry.
Wrong with number 9?
I just know.
What about wrong?
Oh, it's because
We just have to use the Y.
I forgot it.
Uh-huh.
Oh.
Okay, so for instance, number 3. Okay, we were asked to set up the definite integral. And what is the definite integral for this on the area of that thing?
From -4. Well,
From -4 to 4. Okay.
Parentheses. 4 minus.
Yeah, just right what's there. 4 minus absolute value of x.
X.
Yeah, but you need parentheses. Thank you, Ms. Liz. And dx at the end. That's it. Okay. This is sort of where we left off with the confusion about the rectangles. Okay. You're always going to have the height, the function, okay, that's the height of the rectangles. And then dx is the infinitely skinny width of the rectangles. And that's what we're adding up. We're going to figure out how to do that soon. But in the meantime, how would you find the area of this? We don't know how to integrate absolute value of something. What was that, James?
It's a triangle.
Yeah, it's a couple triangles.
Should we do this as
Up to you. You can think about that as 2 separate triangles or as 1 triangle. Matters not. If we think about this as 1 upside down triangle, so we know that the area is going to be 1/2 the base times the height. Well, what's the base? 8. Because it goes from -4 to 4. And what's the height? 4. If nothing else, you know when you plug in 0 into the equation that they gave us, you get 4 minus 0. That's 4. So I'm going to call that an area of 16. This thing here is just notation. That's all it is. It denotes we're looking for the area. Okay? Means we're looking for the area between -4 and 4 of that function. That's what it means. Now, on the other hand, numero 9 is different. Okay, one of these things isn't like the others. Okay, this is the area. So, how did we set this up? Somebody who set it up? Yeah. Okay, just look at it and what's the... Okay, so up here is a 2. Okay, 0 to 2. Y cubed. If we were to draw the rectangles in, not all of them, just like one representative one, because we're going to need to. Okay. Make sure that you draw it in correctly. Wow, that's a straight line. Okay.
What is that for rectangle?
Yes. Right, the width is now in the dy direction, right? That infinitely skinny width is now in the dy direction. Which is why one of our things, length or width, is dy. And then the length of this thing is what? I mean, yes, it's y cubed, but how are we getting that? Say that again, Jordan? What did Teddy say? Yeah, how are we getting that, though? What might we call this point? If I were to name that point Fred, or something else, I might call it XY. Indeed. Right? Any point I could call XY. But this one in particular I'm going to call XY. If I call this point XY, what's this point over here? 0, y. Yeah. Right? If this is x, y, one over there is 0, y. And then now, what's the length? Yeah, x minus 0, or it's always big minus small. X minus 0, or just x. So that's where we're getting the y cubed, because we were told that x is y cubed. Right? But it's not always going to be just whatever function they give us, because this thing could have been shifted over or some other monstrous thing. Right? We're always going to have to identify what the height is that we're talking about, or what the length is that we're talking about. Okay. Is that all I wanted to do with those?
Was that important for the X?
We're talking about a horizontal distance, right? So it's going to be this horizontal part minus that horizontal part.
If they give you a different equation where it was like a function of x and not y, could you do like it from on the x-axis? Does that make sense?
Maybe.
Like, would there be a way to do it where you don't have to use dy, like you could use dx?
For this particular one?
Yeah.
Sure. One of the things we're going to think about. Not too hard, but we're going to have to think about it. Okay, this is still the area that we want. And if we wanted to use up and down rectangles, like that, so we're using dx. Okay. Well, now we have to figure out what the height of that rectangle is. And how are we going to figure out what the height of that rectangle is? At any given place. I mean, let's get started off. We're going to start off the same way. The point that touches the curve, what are we going to call it? XY. And then what other point might be useful to know? The top one, which is going to be what? Yeah, what is that something? Hint, it was sort of up here. 2, right? The top of that thing is 2? Okay. So the width of that thing is dx now. What's the height? 2 minus y, indeed. So if we integrate, what's this point over here so we make sure that we get everything in here? How far does it go? It goes 8. So we're going to go from 0 to 8. Of the height, which we said was 2 minus y. Now we're integrating dx. So we can't have a y in there, we need an x. Do we have an equation that can help us replace the y with an x? Yeah, I mean, we have that x equals y cubed. In other words, what's y equal to? Cube root of x to the 1/3. So that's what we would plug in here. We would say that this is the integral from 0 to 8 of 2 minus x to the 1/3 dx. And this integral will get us the exact same answer as this integral. Okay, they get us the same answer. Just one is integrating dy, the other one is integrating dx. Okay? We're like drawing an infinite number of rectangles this way, or an infinite number of rectangles this way. So if we did those two integrals out, we get the same area. It just sort of depends on which one might be easier to set up. That's it. Other questions? The setup part is important, especially because, for instance, for this one, we can't rely on geometry. Okay, for number 3, we could rely on geometry because, it was a triangle. We know how to find the area of a triangle. With this one, it's not a triangle, it's some curvy shape. The only way we're going to be able to figure out the area is by doing this thing, which we know means antiderivative. And that is what we will be talking about on Monday. Okay, here's the plan. Stan. Don't start making noise yet, but yes, we're going to take a little break. When you come back, please go onto the class website. Actually, I even have it as a homework assignment that's due Monday, where it's class feedback time. So go there, click the link, give your feedback. Right? Those two things combined will take 10 minutes maybe. So we're going to start back up at 10 till 1. Okay? And then we're going to talk a little bit about the link between area and integrals. And why in the world they're related. Yes, turn in homework too. Up here in the front. Yeah, I mean, it's on the resources tab under links.
Can I
It's
do it on my,
also,
do you know if I can do it on my phone?
yeah, you should be able to. But I would like comments.
Can I comment on my phone?
Usually Android standard Wellington.
Yep. Hold on. If you didn't put your homework at the front, now is the time.
Sam, remember in French class when I was saying?
No, don't sing that song.
Don't get much choice in there.
I forgot about it.
Is it on the class website?
It's an assignment for Monday.
Oh, my bag. You should have joined sex class. Yeah, Mr. Feeling. I don't see it.
Don't want the
Let's do Monday.
I don't have an assignment. Monday's right.
Are we in advanced calculus too?
Yeah.
There's like 7 assignments most of the document. Scratch it. Start this
I hate the flats. Said hard. They're strong. They're difficult. I'm all just
Mundane.
I don't know what that
I'm gonna say fail.
I think that's right.
Low grade. Wait, that's
Mundane means lacking interest or excitement. Or dull.
You have to say cry.
That's so mean.
I'm gonna say
Yeah.
I'm learning.
Yeah, everyone's love for
5,000 things.
Just not too many.
But I don't know what to say.
My grade is
Yeah. Test quiz. I guess the grades right as not on.
Humdrum.
Is there a room where we can't have homework?
It's, I think it's only if you practice.
Ooh.
Timing classes. Yes. No, 1 minute.
How we doing?
A lot of pages from that. Okay.
How much more time do we need? Do not say 20 minutes.
Probably like
5 minutes.
Probably like 19.
Yeah.
7.
Let's go. I'll be back at 5 till.
Oh, I know. No, I know. I should probably do that.
My grade group.
No, it looks
Booyah!
This course does not hold my interest.
I literally just said no.
Jared, that is relevant to my life. Like, no.
Wait, is there supposed to be a question here? It's hard to.
Does not hold my interest. Wait, so like if I strongly
Yes,
agree.
yeah, there's
You're in your will.
Okay.
Oh, yeah.
Is this relevant to my life?
No.
I think maybe.
I put grade, but I'm just like purple was
I never find these. Did you leave the middle?
Originally, that was a comment. They always.
Why is it two?
I don't know.
Oh my gosh,
No.
You're like,
No. It's just.
it's just not never.
Oh, Miss Lynn is gonna hear it from me.
Yeah, I've done.
Oh, yeah.
No, there's like an extra comment box.
Oh, be sure to mention.
Oh. 5 words.
Oh my God, Jordan, are you still thinking?
I'm
I'm not
actually
even
writing.
roasting Nando right now. I'm roasting someone in this class. I'm just ending with, so if we could keep the condescending comments to a minimum, that'd be nice.
Why is my voice playing?
She's not here.
Dude, come on.
Yeah.
I caught a whiff.
Whenever someone guesses something and it's wrong, she goes, no. Like, okay, bitch. Sorry, I won't talk. That actually sounded so much like
That was really accurate. Yeah,
Oh
and
yeah, dude. What the fuck is even here? Normal.
No, I don't get what you back.
Yeah, I'm trying to
The more
What process?
some.
Oh my god. I hate you. Oh my. Like. Yeah, dude.
What?
I sent you a fan lotion in your mouth.
Yeah, I do, but Megan's crusty finger paint.
Because look at what I just Instagram DM'd you. It's funny. I'm not
It's funny, isn't it? Yeah.
What is for There was no step. Why? What obligation? Oh, you're
I don't see an Instagram date.
Did I send it to the wrong person?
What is wrong?
Beef stew. The stuff that's literally just brown.
Oh, I see it. There's
whole
it.
plate. The only good thing about this one is I kind of Maddie, the one down said.
I would die.
Oh my gosh. Oh, my gosh.
I know, I thought it was
Oh, I can see that. No, it's beef stew. I remember her saying.
I'm still roasted.
I literally
Maybe
I put
it's
sometimes.
I roasted.
And then
What are you things? Any good?
Yeah.
but
You put that together.
Oh,
No.
Yeah, I smell it.
I literally have not.
Oh wait, that is what I was
Yeah.
Cross the outside, and then you get the.
Wait, what is
literally
any time I go on stuff?
Yeah, but it's not like it's good. I'm sorry, I keep getting distracted by things.
Do you not like that word?
I
Other
was
girls-
here.
Here, where are you from?
Did that count?
Yeah, I forgot my wallet.
Okay.
Cornbread, is that for all of us?
I can't give up. I'm
Well,
gonna
I
clash
thought
that.
you cannot sit in front of me eating cornbread.
Me
Cornbread?
too.
I'm so hungry. Yeah, I forgot my wallet.
Me too.
Wait, that's
Wait,
what
I
you
went
went
to get
to
cornbread
lunch.
before I could.
Sign out.
Okay.
Yeah.
Thank you for leaving feedback. I will take a look at that over the weekend.
That's what I want.
Now, just so we have a foretaste of what we'll be doing, what we will be doing over the next month or so. We have what we call affectionately the fundamental theorem of calculus. The fundamental theorem of arithmetic is that every integer can be factored uniquely into primes. For instance, 18 is 2 times 3 times 3. Can't be anything else. That's the fundamental theorem of arithmetic. Fundamental theorem of algebra is more annoying. It has to do with the numbers of roots of polynomials. The fundamental theorem of calculus takes two completely different ideas and joins them together. Okay. Obviously, there are some reasons why they're joined together, but just thinking about them initially, there's no reason to think why they would go together. And this is it, stated in English. If you can set up an area as an antiderivative, right inside that integral sign, okay, then if you just find the antiderivative,
Area is the antiderivative at the end of what?
at the end of the region.
Okay.
So we're going to find the antiderivative. Okay. And then we're going to stick in the ending x value and figure out what that is. Then we're going to stick in the beginning x value, figure out what that is, and we're going to subtract them. And that's how we can find the area underneath a function. Okay? More mathy, stated this way. Okay. Like on the quiz, I didn't have numbers down here, the A and B. Right? It was just the antiderivative, okay, and we ended up with like a plus C, right?
What's that?
What was that?
Is the F there?
Yeah, like the big.
Yeah, 'cause that's the capital F. Right? So that's how we're going to be able to find the area under a curve. And it's so important. Give it its own little initials. The FTC, Fundamental Theorem of Calculus. So let's do 1, and then we'll be done for the day.
Yeah.
1 is done. Just so that we see it done. Okay, everybody have this down?
Yes. Just like
Let's say we have this function.
It's just like maybe.
Gravel, in case you couldn't guess. If I factored that thing, completed the square, we would see that it's been shifted over 1 to the right, and it's been shifted up 2. So it looks like this. That thing looks like. I would like to know what the area from 1 to 3 is. Here it is, 3. This area here. Okay, how do we set this up using the integral symbol? Like we did. Yeah, I mean, first of all, we've got this thing. Yeah, the 1 and the 3. Okay, now what goes in? What goes inside?
That equation.
Yeah, the function. Yeah, make sure that you've got parentheses in there. And dx. You need the dx every step until you actually take the integral. Okay, well, according to the fundamental theorem of calculus, we should be able to find the antiderivative of this thing, evaluate it at 3, plug 3 in, and evaluate it at 1, and subtract those two things, which gives the area. This is how we write that. Okay, that 1 and 3, just a straight line at the end, that just means that we're going to evaluate it twice. We're going to evaluate it at the 3, and then we're going to evaluate it at the 1. The stuff that goes here is the antiderivative. So, what's the antiderivative 1/3 x cubed. Me likey. Minus x squared. Yeah, plus 3x. C. How are you going to get a number out of this? Got a C in there. I haven't given. It's not like I've given you a starting function value or something. Well, let's see what happens. Okay, first we're going to evaluate it at 3. So, everywhere you see an x, stick in a 3. Oh, well, ain't that fine? How do you do? And then we're going to subtract. What happens when you stick in a 1? Well, what are we getting here? Somebody talk to me about the C's. Yeah, I got a plus C and a minus C. And that will always happen. Every time. Right? Because it's a C. There's no X involved. So whatever else we're sticking in for X, we're going to be left with a plus C on the first thing. And from that, then we're going to subtract another plus C. So the C's are always going to cancel. In fact, we don't need to write this at all. Not needed for definite integral. Okay, it's still needed if we don't have numbers, like the 1 and the 3 in this particular example. You still need the plus C. Totally need the plus C. If this 1 and 3 weren't here, you still need the plus C. But if we're going to be evaluating it at one number and then subtracting it off, evaluating it at another number, then they're always going to cancel, so you don't need to write it. Okay, so what number are we getting here? I'm getting a 9 minus a third minus 2. 6 2/3. Which I'm going to call 20/3. That is the area. Underneath that parabola, we have a nice looking area there, just 20/3. Okay. Alright, we'll be practicing more of that on Monday. In the meantime, the homework for Monday will look relatively familiar because, for instance, numbers 1 through 9 are on it again, but this time you'll actually find the area.
How simple is the project for area?
It'll be like this. Yeah, and we'll go over the homework first.